NASA just found a planet with never-ending storms is a discovery that raises astronomical, meteorological, and exoplanetary concerns about the extreme weather conditions on alien worlds. Using advanced space telescopes such as James Webb Space Telescope, JWST, and Hubble, NASA has detected an exoplanet where violent storms rage continuously across its surface. This newly discovered world, located hundreds of light years away, appears to have a perpetual storm system, dwarfing any weather event seen on Earth. Scientists believe that these storms are driven by intense atmospheric dynamics, high-speed winds, and extreme temperature contrasts between the planet's day and night sides. Unlike Earth, where hurricanes, cyclones, and thunderstorms are temporary, this planet's storms appear to be constant, never dissipating due to stable atmospheric conditions. NASA researchers suggest that massive temperature differences between the planet's equator and poles may fuel permanent superstorms, similar to Jupiter's Great Red Spot. Jupiter's storm has persisted for over 300 years, but on this exoplanet, storms may have existed for millions, or even billions of years, without stopping. The planet's atmosphere is likely composed of thick layers of volatile gases, including hydrogen, helium, and possibly methane, ammonia, or carbon monoxide. Extreme wind speeds exceeding thousands of miles per hour have been detected, making this one of the most hostile and dynamic weather systems ever observed. Some scientists speculate that the planet might experience continuous lightning activity, with electric discharges far more intense than anything seen on Earth. If confirmed, this would suggest that the planet's atmosphere is highly charged, generating massive storms with electromagnetic bursts detectable from deep space. NASA's findings indicate that dark clouds of metallic compounds, such as silicate and iron vapor, may be forming in the upper atmosphere, leading to rain made of molten metal or glass. Some researchers compare these conditions to hot Jupiters, gas giants that orbit close to their parent stars, where extreme heat and high-speed winds create perpetual chaos. However, unlike other exoplanets with seasonal storms, this world appears to have no calm period, with extreme weather dominating its climate at all times. The discovery challenges existing climate models, as most planets experience atmospheric shifts and pressure changes that eventually break up storms over time. On Earth, hurricanes and cyclones weaken due to land interaction, cooler waters, or loss of heat sources, but this exoplanet's storms never encounter stabilizing forces. Some astronomers theorize that the planet's rapid rotation and tidal locking may play a role, creating a system where storms are continuously fueled by heat and turbulence. If the planet is tidally locked, meaning one side always faces its star, the contrast between the hot and cold hemispheres could generate superstorms that never weaken. JWST's spectroscopic analysis suggests that the planet's dense atmosphere traps heat, preventing storm systems from dissipating and leading to endless violent weather. The planet may also experience massive pressure waves, causing towering storm clouds that stretch hundreds of miles into the atmosphere, constantly reshaping their structure. Some exoplanet researchers believe that such planets could help us understand extreme climate behavior, including what might happen to Earth in distant future scenarios. If Earth's atmosphere were to become thicker due to runaway greenhouse effects, could our planet one day experience endless storms as well? The study of extreme exoplanet weather can also provide insights into early planetary formation, as storm dynamics influence atmospheric composition and heat distribution. NASA's next goal is to determine whether this exoplanet storms are static, moving in predictable patterns, or if they migrate over time like weather fronts on Earth. Further observations using infrared and radio telescopes will help scientists determine how deep these storms extend into the planet's atmosphere. The planet's extreme weather patterns could also impact any potential for life, as continuous storms would make surface conditions highly unstable. Some researchers argue that if liquid water exists beneath the stormy atmosphere, it could host life forms adapted to extreme pressure and wind conditions. Certain Earth organisms, such as extremophiles found in deep ocean trenches and high-altitude clouds, demonstrate that life can survive in harsh conditions. If similar adaptations exist on exoplanets, could alien life evolve to thrive in permanent storm environments, feeding off charged particles or atmospheric energy? While this planet is unlikely to support complex life, its discovery raises questions about how planets evolve differently based on their atmospheric conditions. NASA plans to observe other exoplanets with similar characteristics, searching for patterns that might explain why some worlds have perpetual storms while others do not. The findings could also influence the design of future interstellar probes, as spacecraft exploring gas giants or exoplanets will need to withstand extreme weather conditions. Astronomers are now comparing this exoplanet to known gas giants like Saturn and Neptune, which also experience intense storms but on a shorter time scale. Saturn's hexagonal storm at its north pole has remained stable for decades, suggesting that some planetary storm systems can persist without breaking apart. Some scientists theorize that the exoplanet storm system could be linked to deep atmospheric convection, where rising and sinking gases sustain violent weather. Understanding this planet's extreme meteorology may help improve climate modeling on Earth, particularly regarding how storms intensify and sustain themselves. The discovery of a planet with never-ending storms also provides insights into the dynamics of planetary atmospheres and how they evolve over time. By studying these worlds, scientists hope to determine whether perpetual storms are rare anomalies or common occurrences in the universe. If other exoplanets with similar weather patterns are found, it could indicate that certain atmospheric conditions naturally lead to infinite storm cycles. Ultimately, the debate is not just about whether storms can last forever, but about how planetary weather shapes the evolution and habitability of worlds beyond our solar system. The real question is whether this exoplanet's extreme climate is a unique outlier or a window into the violent atmospheric processes that govern many worlds across the galaxy.